Hi, everybody. This is Group 46 presenting to you our software, Tom and Jerry. Now, the idea of this software is to implement a game where we pit two characters, Tom and Jerry, on both sides of a randomly generated map. The objective of Tom is to catch Jerry, and the objective of Jerry is to escape Tom through the exit, which is on Tom's side. The special part of our program is that we implement 8 difficulty levels for users of different skills so they can all enjoy the game together. What's more, the map is randomly generalized instead of manually generalized, so it's more user-friendly to the user. We also implement the entry and exit point at the center of the map to fully utilize the map's functions. Next, we'll briefly describe how we actually implement this algorithm. Anson?
So for my function A, which is the maze generation, I have choose the MST algorithm. And for the MST algorithm, I have used the Prim's algorithm to do the MST sorting and the MST generation. So first, we need to choose a vertex from the matrix, and then we'll add it to the empty set visited. And then we choose the edge with the smaller way from the to visit array, and then connects a vertex from the to visit with another vertex not in the visited. And then the third step is to add that edge to the visited and then assign the weight which we have created, because we have created paths, we have a path, and then we will assign the weight to the wall in the 4 direction of the designated vertex of the edge to the set to vertex to visit. And then we will repeat the step 2 and 3 until all the vertex in the matrix we have already included in our visit, and this is how my MST algorithm works.
Well, for function B, we implement a breadth-first search algorithm. So we first visit each vertex, then we visit the vertexes that are connected to it. Because it's a breadth-first search algorithm, when the exit point is reached, it's guaranteed to be the shortest path. We use a queue structure to go through the breadth-first search algorithm, and we use a stack structure to store all the queue nodes we have visited, reducing the time complexity. This is how we implement function B.
For function C, I create a game class to store all the data and handle all the game logic in the game. And the maze is where I implement the internal data structure of the base map. The core of function C is inside the gameplay function. To let Tom run faster than Jerry, we decided to give Tom a bonus step after each number of difficulty level turns. This makes sure that Tom can run faster in the long term. This is basically how I implement function C.
In conclusion, obviously you can see that we have learned a lot about Java programming and the use of GitHubs, but we have also much more takeaways. Anson?
So the main takeaways of my things is when I'm doing our function, and then when we want to merge our function, I find that there's something that we are using in a similar way, but we have implemented in a different way. And then when we merge them, we need to do extra work and many works to do it. And this means, and then after the whole merging, I found that if we can do it with more smooth way, which is we have more complication and then more planning before our doing our function and building our program, then we can do the all the process and more smoothly, and then we can manage our work progress more easily. So how about you guys?
For me, during the project, I understand the importance of documentation, as it's really hard to understand and integrate different functional modules written by the others. Also, proper version control really help us to save tons of time and make it possible to use the same component across the whole program.
Well, for me, it's more about teamwork. Remember the time that when we called the emergency meeting because function B malfunctioned? It was really late at night, and you guys came rushing to the library to help me out. That's the only reason why we could fix the problem so easily. That's when I realized that if you can only sacrifice a little bit of your interest to help everybody in the group, that's how teamworks actually succeed. And that's how we actually succeeded. Thank you.